Okay class, this will be a video explaining how to use the Logicola program to do truth table evaluations for entire arguments rather than just singular sets of claims. So here is how this one works, and actually I've probably got this on too hard right now, so I'm going to turn it down. Yeah, let's go to easier first. Okay, so here's an example of a simple argument. The first premise is if A is false, then it follows that B is true, and they conclude therefore not A. And I need to evaluate whether this argument is valid or invalid. I can do that with a truth table, and I'm going to show you how to do that here. Same strategy we've been using before with this. So the first thing I'm going to do is going to look at this claim, and I'm going to do all the truth table evaluations for this claim. So what I would do is plug in a 0 and a 0 from this line right here. That's the first one I'm looking at. Drop this down, flip the sign. This equals 0. So this is a false. For the next line, I would do 0 and 1. Flip my sign. This is a 1. So that's 1. And this next one will also be a 1. I'm not going to do it for you. You can do that if you like. That would all be a 1. And I know that because I can just quickly look at it and assess it. For this line, really simple. I'm just going to do 0, 1, 0, 1. Notice I'm just copying these values over. And then in this last line, all of these I could do a little work with. All I should realize is that, well, because this is negated A, what's going to happen is that every time I plug in my actual value, I need to flip it. So this would become 1. So here when I have a 0, because that would be negated, this is 1, and then 1, and then 0, and then 0. Okay. And so now here is the truth table for this argument. I have this line where this premise is false, and the conclusion is true. This line where everything's true. This line where this premise is, true, this premise is false, and that one's conclusion is false. And then this line. And this is actually the line that invalidates this argument. When you're using a truth table to determine whether an argument is invalid, what you're going to do is look for a case where every premise in the argument, in this case I only have 2, where every premise in the argument is true, which I do, and the conclusion is false. So here I have true premise, false conclusion, so that means this argument is invalid. And it's going to be this line that makes my argument invalid. And the way this works is because an invalid argument is an argument in which it's possible to have true conclusions, true premises and a false conclusion. And I can show that here. It is possible for this premise to be true, that premise to be true, and this conclusion to be false. It's in this case. When A is true and B is true, you generate the invalid version of the argument. And it's even going to tell you which line invalidates it on this program, which is kind of nice. Okay, do another one. Oh, nice. 2 simple premises here. Conclusion's kind of complicated, but the premises are real simple. So I'm just going to plug in for A here, just copy my values. For B, I'm going to alternate 0, 1, 0, 1. This is the one that's going to be more complicated now in terms of for the argument. So this actually has some stuff going on in it. First thing I need to do is put in my values using my first line as my starting line. Okay, these 2. And then I'm going to flip my values on the inside first. So I have a 1, 1. And then since this whole thing is negated, well, since this thing is 1, 1 on the inside, that would actually be equal to 1. And I'm just going to delete all this stuff, which would give me this. I'm going to flip my sign. This is actually a 0. So this first line is a 0. Okay. Then I'm going to do the same thing for the next line. Plug in a 0 for A. Notice that it's flipped here. So I need 0 for A, 1 for B. Next line, flip my sign there, or flip my value, excuse me. So I got that. And the inside now is actually equal to 0, because 0 if and only if 1 is the false case for an if and only if claim. And I'm going to bring this down, and this is going to be negated 0, so that equals 1. Next line, same deal. I'm now doing 1 for A and 0 for B. If you're savvy, you should realize that with a if and only if claim, if this one where it's 0 then 1 is false, then this one is also going to be, is true, then this one's also going to be true. But we can test it. Flip my signs. The inside would now be equal to 0. bring this down, and lo and behold, it is 1, just like the other version was. Okay. And this last one should be a 0. And we'll just test it out here. 1, because the inside will be true, and then we got to negate it. Okay, there's that. That's the inside now is actually equal to 1, because the signs are the same, and it's an if and only if claim. Bring this down. Flip my sign. There's the argument. Now I got to figure out whether it's valid or invalid. What I'm going to do, quick trick here, the only lines in a truth table that can invalidate an argument are those where the conclusion is false. Right? Any line where the conclusion is true, I don't have to worry about it invalidating the argument because I need a line where all the premises are true and the conclusion is false to invalidate it. So any line where the conclusion is true automatically can't serve as an invalidating line, don't need to worry about it. So I'm only going to look at these two lines. This line, I've got 2 false premises, that's not going to work. I need all the premises to be true and the conclusion false. So I only have 1 line left to look at, which is this last one. And I have, true premise, false conclusion. This argument's invalid. And it's going to be that last line that did it. Okay. You can again ramp up the difficulty. This is probably as difficult you're going to see on this test or in this class, but you can ramp up the difficulty if you want to make it harder and look at these. So here's a more complicated argument with a much bigger premise. I'll do this one. Just a couple lines of it, and then you can go on and practice these things if you want, just to get even more skilled at this, but you don't have to do one as complicated as this for purposes of this class. Okay, but what I would do is, I'm actually going to go over here first, if it'll let me. It doesn't. So I have to do all of these first, unfortunately, and then I would just plug in my values for A. And this would actually be a really long argument to fully fill out, because I have to do all of these values because there's 3 of them. So I'm just going to do 1 line to show you how you would do it, and then if you want to do this, knock yourself out. So for this line, I'm going to plug in all the zeros. Once I've done that, bring it down, start switching the values. Okay. And I'm going to work inside the parentheses first, way out. So I have a 1 and 1 here. This would actually equal 1. So I would have this, which equals 1. So this whole thing here would be 1. And you would go on and do it for the rest of the thing. That should do it. If you've got any further questions about how to use Logicola for truth tables, shoot me an email and I would do my best to explain.